All right, today we're going to look a little bit at deductive reasoning. Within deductive reasoning, we're going to use the definition of deductive reasoning, first of all, to draw some conclusions. And then we're going to look at specifically the laws of detachment, the laws of syllogism to draw conclusions as far as the validity of arguments go as well. So, first of all, let's define this. Deductive reasoning is when we use facts, definitions, or properties to reach a valid conclusion from given statements. Okay, deductive reasoning is what's accepted, if you will, in a court of law. Because if you think about it, you gotta. If you ever watch a court case, you have to, submit any evidence. They have to be, they reference other rules and rulings that have already occurred. Everything's got to be official and based on facts. Okay, a valid argument. An argument is valid in which one excuse me, in which it's impossible for all the premises or supporting statements of the argument to be true and its conclusion to be false. Otherwise, or in other words, if all the given information is true and the argument is that's based upon a valid concept, then that conclusion has to be true. It cannot be false. And we'll look at some examples of how we're going to use this here in a bit. Like I said, arguments can be proven true using two different laws. It's the law of detachment and the law of syllogism. We're going to get to those in a second. But the first thing we're going to do is use our deductive reasoning concept and the valid argument concept to make some conclusions as well. All right. So let's start with this first example here. It says let P and Q be the following statements. Okay. P is the conference is in Sydney. Q is Raina is a presenter. Okay. All right. Based on these two statements, let's consider this argument. If the conference is in Sydney, then Raina is a presenter. Premise two, the conference is in Sydney. The conclusion drawn is therefore Raina is a presenter. Now, what we want to do is analyze this argument and prove that it's valid. Okay. So the first thing we're going to do is write it out in symbolic form. So premise one is an if then statement. If the conference is in Sydney, then Rain is a presenter. So it would be if P, then Q. The second premise is the conference is in Sydney. That's just the P statement. So the second premise is P has occurred. The conclusion is Raina is a presenter. That's just the Q statement. So we're concluding Q has occurred. All right. So we use our symbolism here to be able to write this out. Okay. So this is the same thing. I just moved to a new page here. All right. Now, we can express the conditional statement in this form. So, what we're saying is if premise one and premise two are true, then the conclusion must be true. So, that's kind of how this reads. All right. And what we're going to do is set up a table and work through the truth values for this statement. All right. So, what I did is I have in P implies Q. I have P implies Q and P because, again, it was premise one and premise two. That's what this is. And then I take premise one and premise two implies the conclusion, which is Q. All right. So we're going to complete each of these rows and see where we are in the end. All right. First thing is P implies Q. Remember, this is only false if the uh, hypothesis is true and conclusion is false. So for this, true implies true is true. True implies false is false. False implies true is true. False implies false is true. Remember, we talked about breaking a promise here. Okay. Is the promise kept or is it broke? And this is the only time it's broke here. All right. Now, we're going to take the P implies Q column right here true, false, true, true and join it with P and the word and. So P implies Q and P. So true and true is true. False and true, false. True and false, false. True and false, false. Remember, for and to be true, both statements had to be true. All right. Now it's this column implies Q. Okay. So these results imply Q. So true implies true is true. False implies false is true. False implies true is true. False implies false is true. Remember, the only time it's false is if it's true implies false. So these are all true. So the question is this a valid argument? And the answer is yeah. We determined it by looking at this final column. Okay. These are all trues. So in this scenario, from the given information, all possible outcomes come out to be true. Therefore, we got a valid argument. Okay. So that's how we can work through this. And you'll get some that look like this tonight. I'm going to do another one here with you. Okay. So P and Q are the following statements: Frank is hiking. Q, Lucy's in karate class. All right. This is our argument. Premise one: if Frank is hiking, then Lucy's in karate class. Premise two: Lucy is not in karate class. Conclusion: Frank is not hiking. Okay. So first step is to write it out in symbolic form. Okay. So premise one is an if then statement. So if Frank is hiking, that's P. Then Lucy's in karate class, that's Q. So it's P implies Q. Premise two: Lucy is not in karate class. That's the negation of Q. Lucy is in karate class. Lucy is not in karate class. That's the negation of Q. The conclusion is Frank is not hiking. Well, Frank is hiking in statement P, not hiking, negation of P. Okay, so premise one, P implies Q. Premise two is negation of Q. The conclusion from these two is negation of P. We want to see if this is a valid argument. Okay, so if it's a valid argument, we should be able to take premise one and premise two, and it should imply the conclusion. Okay, see what happens when we put it all together here. All right, so here's the truth table. Now, I really broke this one into different columns, and I kind of did it as we were going to use it. All right, so premise one is P implies Q. So here's P implies Q, right? True implies true is true. True implies false. There's the only false one. False to true, false to false. So here's P implies Q. Now I put the negation of Q in the next column because that's what we do next. It's remember it's premise one and premise two. So premise two is P implies Q and the negation of Q. All right. So let's do the negation of Q first. Those come right from the Q column, right? Negation means opposite. So true becomes false, false becomes true, false, that becomes true. Now we're going to join these two columns with the word and to get this column. Okay. So true and false, false, false and true, false, true and false is false, true and true, true. Okay. Now, the next thing we do is take the negation of P and Q, and that should imply the negation of P. So I want to see what the negation of P is so I can join the two columns together to get my third one. So the negation of P, we'll go back here. True is false, true is false, false is true, false is true. Okay. Now, so the negation of P and Q, and excuse me, P implies Q and negation of Q are these answers. Negation of P are these answers. Now I want to do this column implies this column. So if false, then false is true. If false, then false, true. If false, then true, true. If true, then true is true. So my final column here shows me that I have all truths here. So that means it's a valid argument. Okay. You're going to be asked to set up and work through this today, but the program does a pretty good job of bringing you through it so that it's not too bad to deal with. Okay. All right. Now let's get to the law of detachment. So the law of detachment deals with the conditional statement and then just a true statement. So what it says is if we know that P implies Q is a true statement and we know P is a true statement, then Q must be true. So by the law of detachment, we can conclude that Q is true. All right. So let's look at this example here. To go on a field trip, a student must have a permission slip. Mariana turned in her permission slip. The conclusion: Mariana goes on a field trip. So the question is, does this first statement, is this if P then Q and then P is true? Okay. So P is the student turns in a permission slip and Q is the student can go on a field trip. Okay. Since a student turns in a permission slip, then they can go on the field trip. And we know Maria turned in her permission slip, then we can conclude that Maria can go on a field trip. That's by the law of detachment. Okay. The law of syllogism is next. And the difference here is these are two conditional statements. So if P implies Q and Q implies R, if these are true statements, then we can conclude that P implies R. So P implies Q, Q implies R. So these are the same statements. The conclusion of the first statement is the hypothesis of the second. And if that's true, then we can say P implies R. So, for example, if Ebony takes a vacation, then she will go to the Grand Canyon. If Ebony goes to the Grand Canyon, then she will hike the Colorado River. So notice it's P is she takes a vacation, Q is she goes to the Grand Canyon, and then the second conditional is Q implies R, if you will. Our conclusion then is if Ebony takes a vacation, then she can go to the Colorado River, okay, or she'll hike it. Okay, here's some questions now that kind of use the last two concepts we just talked about. It says, suppose that these statements are true. So we're not trying to decide if this is true. They're telling us this is true. So it is true that if Doug knows how to dance, then the tires are old. That's true. And it's also true if the tires are old, then my favorite movie's being shown. The question is, based on these statements being true, what conclusion can we draw, or what other statement down here would be true? Well, when I see two conditional statements tied together like this, I immediately think about the law of syllogism. Okay. P implies Q. So Doug dancing implies tires are old. Tires are old implies that my favorite movie's shown. So therefore, I can now conclude that if Doug knows how to dance, then my favorite movie's being shown. That has to be true. Okay. So if Doug knows how to dance, then my favorite movie's being played or shown. That's what I get out of this one. And it's by the law of syllogism. Okay. Another one. They're saying, suppose this is true. If Jessica is a doctor, then the mouse escaped from the cat. That's a true statement. Okay. What else must be true? Well, since they only give us one conditional statement and nothing else, then I start thinking about related conditionals, right? If this is the original, if Jessica is a doctor, then the mouse escaped the cat. Then the converse would be if the mouse escaped the cat, then Jessica's a doctor. The inverse would be if Jessica's not a doctor, then the mouse did not escape the cat. And the contrapositive would be if the mouse did not escape the cat, then Jessica's not a doctor. Okay. So remember writing those out. We did those not too long ago. And then furthermore, hopefully you remember that the original statement and the contrapositive always have the same truth value. Okay. So if this original statement is true, and they tell us it is, then the contrapositive of that has to be true. So what's the contrapositive of this statement? Well, it's going to be when I switch the hypothesis conclusion and negate them both. So if the mouse did not escape the cat, then Jessica's not a doctor. That's the contrapositive. That's got to be true if that's true. So they bring the related conditionals into this type of questioning. One last example. So again, suppose these statements are true. If the bike is fast, then Yoko sleeps on the floor. The bike is fast. Okay, so they give us a conditional statement and then just a statement. Okay, whenever I see that, I think law of detachment. If P implies Q is true and P is true. So if the hypothesis uh, uh, means the conclusion has to be true, and they tell us the hypothesis is true, then the conclusion has to be true. So if the bike is fast and Yoko sleeps on the floor, P implies Q. They're telling us it's true. The bike is fast. That's true. And that's P. So therefore, the conclusion must be true, which is Yoko sleeps on the floor. Okay. So that's working through some of those concepts. All right. So we're going to have some homework on tonight. There's not many questions to do with this, and they're all based on the examples that I've already shown you. Okay. So watch the video, write things down, look through the homework, take your time with it, go back and review what you need to review, and let's make sure we get that done. All right. I'll let you get at it.